So thanks everyone for coming. So this workshop is going to be essentially show you how you can use Python in a functional way. So using the functional programming properties of Python to do some data analysis. So first I'll just tell you a little bit about myself. I'm the managing director of Reuben Development, and Reuben Development is a data analytics firm, and we specialize in data processing and visualization. I'm also the founder of Arusha Coders. So I'm from Illinois, city called Peoria. For the past, I guess, 8 years or so, I've been living in Tanzania, which is in East Africa, and the city's Arusha. And I started a meetup there, and it's essentially a community of programmers, developers, designers, and that's called Arusha Coders. And I'm the author of several popular Python packages. So I'm going to be talking about one of those today, which is called Meza, and I'll get more into that in the talk. What it is a library for doing data analysis. And I like to think of it as a lightweight alternative to Pandas. So let me just get a show of hands. How many people here you have used Python and are familiar with it? Okay, so there's going to be kind of two parts. The first part is going to be kind of basic, and then the next part will be more advanced. So don't worry if if you feel that it might be too much. There's going to be solutions in the GitHub repo. So if there's anything you don't understand, you can just kind of go back and review the solutions, and I'll also be happy to explain things in more detail. Okay, so first. So this is going to be about data processing, so I guess it would just be good to kind of tell you the way I see data. One of my pet peeves is a lot of people, online everywhere talk about big data this, big data that. I'm not really someone who subscribes to the term big data. I just think of everything as data, unless you're like Facebook or Google or Twitter, which for the most part, most people aren't. So anything that deals with big data or Spark or compiling Java, I just tend to stay away from all of that. So the way that I actually like to think about data is kind of breaking out into a couple different ways. So the first way is how it's organized. You can generally look at data as being structured or unstructured. So this is just an example of structured data. And structured data is something that you can represent in a tabular form. And this table is just showing a few different talks. One field is language and the other field is presenters. And so these are workshops that are happening right now. So these are ones that you decided to skip and instead come to this workshop. And unstructured data is something that you generally can't represent in a tabular form. And usually you just have free text. And this is just part of the description also of one of the workshops that's also going on right now. The other way I like to think about data is how you store it. So you can either have a flat or textual representation, and what that means is something that you can open in your text editor and you can read the data. It's just plain English. You can modify it and just save it back. The alternative way is binary data. So if you opened a binary file in a text editor, you wouldn't actually see human readable text. You would see kind of the binary representation. And those are the two main ways you have to store it. So once you look at both of those together, then you get a matrix of sorts. And so if you have structured binary data, then you see something like SQLite. Structured flat data, so this could be CSV or XML, JSON, etc. Unstructured flat data, which is something like a text file or even Markdown. And then finally, unstructured binary data, which is probably the worst type of data you would want to work with. So this would be something like Microsoft Word. Okay, so it's great that you can do data processing, but what is it actually good for? So this is one thing. I actually haven't used it, but I read a really great blog article kind of describing it, and I thought it was pretty interesting. So Spotify has something that's called a Discover Weekly. And essentially what it is they use a lot of data processing techniques to every week generate a playlist of songs that you haven't heard, but you probably would like. And it does some pretty cool stuff. So one of the things that kind of adapts to your tastes as they shift over time. So if you kind of start liking different genres or different types of music, it adapts to that, and then it will suggest other songs that kind of meet, match those preferences. And also, it's smart enough to know that if you listen to some nursery school songs, that maybe it's your son or daughter who had control of your account, or if you listen to Christmas songs in December, it's not going to play you those throughout the rest of the next year. But it does some really interesting things, and it all uses a lot of data processing techniques. And so next, since this is a functional programming conference, just like to tell you some of the ways I think that functional programming would be good. How many people here are familiar with Clojure or ClojureScript? Okay, so a few people. So there's a front-end library written in ClojureScript called Ohm. So for those that aren't familiar, Clojure is a functional programming language which targets the JVM, which is Java, and there's a front-end language which is called ClojureScript. So essentially it lets you write Clojure that compiles to JavaScript. And since it's functional programming and it is based on immutable data structures, they wrote a library called Ohm, which integrates with the React framework. There's a company called Circle CI, which is a continuous integration company, and they wrote their entire front end in Ohm. And so one of the things that it allowed them to do, so first they were able to make their site very fast. So because it deals with immutable data structures, it's able to kind of just calculate the differences from one transition state to the next. So they can do their rendering very, very quickly. It also allows them to kind of serialize the state that a customer might be in. Again, since everything is immutable data structures and it's functional programming, if a customer has an error, the entire state of their UI is essentially saved in the browser. So they're able to do kind of remote debugging just by importing that data structure, which comprises their state. They can load it in and then essentially view the exact situation that the customer is in. And then the third thing it allows them to do is do kind of time travel or undo. And so they can essentially see every screen that the customer saw and kind of simulate every button that they clicked. And this is all possible through using functional programming. Okay, so I know most of you here were kind of know Python. I wasn't sure what the mix was going to be. So this is just going to give you a brief introduction, to how you use Python. So this was for those that were here a little earlier, there's a GitHub repo. If you didn't already see it, you can go there now. So I'll just give you a few seconds. And so the repo has examples. It has all the code. It also has the exercises that we'll be getting into. And it has links for how you can do this online if you don't want to do it in your own Python terminal. Okay, next. So it might be good if I actually show you how to do this. So if you go here, beta.mybinder.org, and then once you get there, if you click on the link, that repository will already be filled in for you. But if it's not, all you really need to do is just give it Rubano and then the LambdaConf tutorial. And what it does, so it opens up a Jupyter binder, and there's 3 notebooks. So I'll just click on this first one, presentation. So once you click on a notebook, what it allows you to do is you can type in Python and then execute it directly in the browser. So and I can just show you if you wanted to add something new. So say I wanted the keys, and then you just press that play button so you can really do all of your Python within the browser. So that's the option if you either in addition to or instead of doing the Python on your computer. Okay, so first I'm just going to show you some kind of naive data processing that you would commonly do in Python. The first is just going to be reading data. And so in this case, what we're going to do is just use URL open to open a file path. It's going to be a JSON API, and then use the JSON standard library to actually load the data. So in this case, all the examples we're going to be using the GitHub API. And so this is just doing a search for all repositories that have data in their name. And we're going to get the first 100 items. And so we just, kind of use and a lot of the code that you see might look a little weird, and just because I need everything to fit within the slide. So if you were writing this on your own, you probably wouldn't do it exactly this way because you could have more characters. But yeah, this is just, a way so I can get the entire URL of the string into a variable. So I load it, use URL open to get F, and so F in this case is a file-like object. And then for those of you who aren't familiar with the way you can do kind of string formatting, so those braces you see, so base replaces that first brace, and then Q replaces that second set of braces. And so if you were actually to look at the link from the GitHub API, it would look something like that. So it's just a list and then a field called items. In Python you call it a dictionary. Within that there's a field called items. And items is the one that has the list of repos. So in the case here, we want to access everything that's under that items. So in order to do that, we use the loads function, and then we call the read attribute on the file-like object. And so in this case, we're only loading 100 items, so it's not that much data. It's not going to take a long time. But if you were loading an endpoint, or maybe you were reading a file from disk that was very, very big, you see where it says that .read, that basically loads everything into memory. So if you were pulling it from a website, you'd have to wait for everything to download. You'd also fill up all of your computer's memory. So all this time, your computer is going to be waiting. And then once it finishes, then you're able to access the data. And so like I said before, we wanted everything that was in that items field. So we just set repos equal to the items field of the data. And then once we get that, we're able to access each individual repository. And so this is just the first item, and we just want to look at the description. And then if you want to look at another attribute, so here we're looking at the name of the repository. Okay, so now we can get into some actual processing. So in this case, I just made a simple function. What it's going to do is kind of calculate some kind of rating for each repository, and it's very simple. All it does is it looks at how many people are watching the repository and then multiplies it by 2. And so the way it works is first it just sets up an empty list called rated, and then as it loops through the repositories, it appends the actual rating into that list, and then when it's finished, it returns the list. So now if we look at the repository list that we already had, and we just want to see the first 5 ratings, then you get something like that. So now we're going to, throw a little wrench in there. Instead of having that initial list that we fetched, we're going to use something from itertools, which is called a function called count. And what count does is it starts from 0 if you don't give it any arguments, and it just kind of increments. So it'll go 0, 1, 2, 3, 4, 5, etc. And it just does that up to infinity. And so in this case, we're creating an infinite iterator of these dictionaries. And so just to keep things simple, I only added the field that the function we created would actually use, which is called watchers. And so what we're going to have is basically an infinite list of repositories. So if you actually pass that through this function that we just created, your computer is going to just sit there because it's looping through the entire list and the list is infinite. So it's never going to end. What you have to do is if you type Control-C, it'll just stop everything, and then you're actually able to get control back to your computer. So that's one thing that's just really bad. The next thing we're going to look at is, okay, well, you know, maybe you don't deal with infinite data. One thing you might deal with is a calculation that is computationally expensive. So in this case, we're going to make a new function, just call it expensive rate. And what we're going to do is just simulate computation by using this sleep function. And before calculating the rate, it's going to sleep for 5 seconds. So now, when you call expensive rate on your original list of repositories, you're going to be waiting a long time. Because even though at the end you see that .5, we only want the first 5 repositories, it's still looping through the entire list. So you're going to wait 5 seconds to calculate the rate of each list. And so in this case, there was 100 repositories, so you're going to be waiting 500 seconds. And so at the end, you know, you still get the same answer, but it just took a lot longer. Okay, so now, you know, that was a naive way. So what are some things you can do to kind of do it the right way? So one of the things you can do is actually use something in functional programming, which is called lazy evaluation. And so just to kind of show you what that looks like in Python. So if you make a list, and so in this case, we just want something 0 through 4. Normal way you could do it, you just, you know, have the list function, and then when you want to view the list, you just kind of type the name of the variable and you get the entire list. If you want to do it lazily, there's a function called iter. So there's different ways you can do it. The example I showed you before when I had that infinite list, that was called a generator comprehension. So that's one way to make a lazy list. Another way is what you see here, which is using the function called iter. So iter just takes any item, in this case, we'll just call it a list, and it turns it into a lazy version. So now when you type in the name of that variable, you don't actually get the list back. What you get back is kind of an object that represents the items in the list. And if you want to get each item from the list, there's a function called next. So when you use the function next, it takes the item that's kind of in that first position. And the way these lazy iterators work in Python, so once you kind of use next to get that item, it disappears from your memory. So that 0 that you see there, there's no way to get it back. So you can see now if you call list on the lazy list, since we viewed that 0, all we have left is just 1, 2, 3, 4. And then if you try to call next again, you get a stop iteration error. And basically that's just saying that the iterator was empty. You tried to call next, there was nothing there. So, it just complains and tells you that, there's nothing there to get. Okay. And so kind of using this concept, we can look at how we read data in a way that's going to be a little bit more efficient. So in this case, Python doesn't have this in the standard library. So the package that this example is going to use is called iJSON. And so once you have iJSON, we're going to do something fairly similar. The main difference is that we have to pass to it the path to the list of data that we eventually want to get. And so you just pass that into the second argument of items. And so kind of like I showed you before in the GitHub API, it was in a field called items. And the way that iJSON works, you have to kind of put item at the end of everything. So even though the field was called items, you add .item at the end. And that's just telling iJSON that the thing you're giving it is going to be a list. And what it does is it will lazily go through the list. So it kind of uses stream processing to kind of incrementally parse the JSON, and will give you back a lazy list of all those items. So you can see here when you call repos, you get back a generator object, and it's just another lazy object. And so we use next to save the first repository into this variable that we're just going to call repo. And so now we can do the same type of dictionary access that we were doing before. So in this case, we're just going to get the name of the repository. Okay, so next we're going to be doing some data processing. So this is the function that I showed you before. And so now we're just going to transform it into a way that works lazily. So first we're going to rename it to generates. So in this case, most functions that kind of operate lazily, one way to kind of indicate that is by putting gen in the front, and that just means generator. So now we're going to get rid of that initial list, going to get rid of the return, and now we're going to yield. So in this case, instead of looping through the list and returning, we're just going to loop through the list and yield. And the way that Python kind of operates with this is whenever it sees that yield, it just kind of stops execution and just kind of hands it over back to the next thing that needs control. And so now when we call generates on that repos, we get back another lazy list. So you might be noticing a theme here. Kind of all of these functions are just kind of operating the same way of generating a lazy list of all these repositories. And just like what we did with iJSON, when you want to kind of do some calculation, you pass it, you save it to a variable, and then you call next. So here we're just getting the next rating, which is just the rating for that first repository. And then every time you call next, then you get the initial one. And so now you can see we pass it that infinite list of repositories, and it doesn't hang. We just call next. And depending on how long you let it run initially, that number you see there, is that maybe 42 million? It'll be smaller or higher depending on how long you let it run initially. So if you stopped it very soon, then you get a much lower number. And now we're going to do the same lazy evaluation, but we want to make it expensive. So just like before, we're going to add sleep. So we're going to say sleep for 5 seconds, before you figure out what the rating is. And because we have lazy lists, we can't use the list slicing that you normally do with Python. So there's another function in ItterTools called iSlice. And what iSlice lets you do is you give it an iterator and you tell it how many items you want to extract. And then it will get just that number. And also, if you have any questions during this, feel free to raise your hand.
Sure. I was wondering, when you got that error from, I think you were at the end of the list of this generator was giving you.
Mm-hmm.
Did you get to the end by listing that lazy array?
Mm-hmm.
But, so by calling that moved like the marker?
Right. Yeah, so there's two ways. So you can get to the end of a lazy iterator either by calling the function list. So iter turns a eager list into a lazy list, and the function list will turn it into an eager list.
Oh.
So yeah, so if you try to call list on an infinite iterator, that will just take forever because it's trying to figure out the entire thing. So the two ways you can get to the end, you just keep calling next, and every time you call next, it'll go one by one until you get to the end, and then you get that exception. Or you can just use the function list. So you should only use list if you know how big that iterator is, because you could be potentially loading, maybe like gigabytes of data, into your memory. So you just have to be careful. So does that answer the question?
Yeah. But so that makes sense, I think. But then when you were saying that depending on how long you ran,
right?
For example, but if it's lazily loaded, then wouldn't it just keep?
Yeah. So in this case, it's 42 million, right? So if it essentially that for loop was doing the same thing as calling next. So if you let it run for, several seconds or several minutes, then it's going to start at 0 and just keep going up. And since iterators don't keep track, once you call next, that number is gone forever, right? So that list initially basically used up all the numbers up to 42 million before you stopped it. So now that infinite list that you had, once you start using it again, it picks up wherever it left off. So in this case, we're picking it up again, and it's at 42 million. If you click next 1,000,000 times, it will go up another 1,000,000. So that's essentially what it's doing, because that previous for loop was the equivalent of just saying next, 42 million times.
Right. Okay.
Does that make?
Yeah.
Previous?
I mean, the slide that is previous to this.
Previous to this? Keep going. So it was essentially this, right? This was the original for loop. So that for repo and repos, so if that's an infinite list, right? So every time it's saying for, it's going to the next one. And so with that infinite list, if you just let it run for a long time, basically what this is simulating is before we just let it run until that, that count variable got up to 42 million. And then when we stopped it, it just stops, because otherwise it would run forever. So now, go back.
When you say stop, you mean Control C.
Control C, exactly. So now, you see we're passing in infinite repos, right? Which is that lazy list. So now, when we did Control C earlier, we did Control C, the counter had gone up to 42 million, whatever. So now we're calling next, and it just says, okay, what's the next number after that?
Oh, you already Control C.
Exactly.
Continuing from that example.
Just continuing from the previous example. Yeah.
Infinite repos is already there.
Exactly. Yeah. Any other questions? Okay. So yeah. So now now we have the generator expression. This time we're gonna make it expensive. So we add in that sleep function. So I talked to you about iSlice. So now we're using the repo. So this is the same repos from the previous example. Most of these examples kind of intend to build on each other, so we don't have to keep redefining things over and over again. So this time we're gonna generate the expensive rates, and we say we only want the first 5. And so now we're gonna wait, but we only have to wait for those 5 items to be rated. We don't have to wait for all 100 items. And since iSlice is in itertools, it also returns a lazy list. So we pass the result of that into the list function just so we can, see what all those items are. So the big difference here is that you can decrease the amount of time you either have to wait, or how much memory you need, or how much processing power you have to use, because you already know that, oh, I just need the first 5 items. I don't need to see the rating for all 100. And the nice thing is, since it's an iterator, when you do need more items, you just call next. So now every time you call next, you only wait 5 seconds. You don't have to wait for all of the items to be rated. So, any questions? Yeah.
So you define rates as a generator, and then you wrap it with iSlice.
We're not.
You,
Okay.
then you can, right?
Mm-hmm.
You consume
So-
everything iSlice was going to do, and then you call next. So
Yeah.
it's actually changing the pointer on your original generator of rates.
Yeah, so essentially rates, so you can see here on the slide, rates is the lazy result of all of the repos. Result is just the first 5. So since rates is an iterator, we consume the first 5, but the rest of the things are still there. And since results is lazy, we use lists to see those 5. And when you call next on rates again, we get the 6th item. So the equivalent way to do this would just be to call next on rates 5 times. But this is just an easy, convenient way to do it. So does that make sense?
Yeah. I was just noticing, I didn't know iSlice worked off the same source. In other words, it's not a new cursor.
Right, exactly. Yeah. So with iterators, that's the way they work. Everything kind of, unless you can use T, right, which basically makes a copy. I won't be talking about that. But if you take an iterator and you save it to multiple variables, when you call next, it doesn't matter. It's still gone, right? So everything is just one structure. Yeah. Any other questions? Okay. So now we're gonna do some grouping. Okay. So in this case, I am gonna recreate the repos because since it's lazy, I want this example to be like a fresh start. So in this case, we're going to get back those 100 items. And so now we want to group each of those 100 items. And so this is just showing you what some of the fields are. So this is all from the GitHub API. So you get the owner of the repository, the name, the URL, how many forks it has, etc. Bunch of keys in there. And the one that we're going to be looking at is the field called has issues. So if there are issues in the repository, this will return true. If there's no issues, then it returns false. And what you want to do is just group all of those repositories by whether or not it has issues. And so here, I'm introducing something new. So there's a function from the operator module called item getter. And the way item getter works is you pass it a string. So in this case, we're passing it has issues. And what it returns is a function. And so we're saving this function into keyfunc. And the way that function works is that function takes a dictionary and it looks up the field has issues and it returns the value. And the reason we're doing this is because we have a list of dictionaries and we want to sort that list according to that field has issues. So let me just pause there. Does anybody have any questions about that? Okay. So once we have it sorted, now we want to group it. And so we pass in the sorted list and we give it the same keyfunc. So the way that grouping works, you can't group an unsorted list. You have to sort it before you group it. Otherwise you'll get some wacky answers. And so now once it's grouped, what it returns is each item in grouped is a tuple. The first item, which is I call it K, which is just the key, and then G is the group. And so I'll show you what those look like. So when you call next on data, so K, which is the key, is false. So this is saying has issues is false. And then the 3, let me just go back here. So we're doing a list comprehension. So this is just saying count how many items are in each group. And we have to call list on G because G is also a lazy iterator. So you can't call len on something lazy. So we have to cast it into a list. Then we use len to count. And so now we see that there are 3 items that didn't have issues. And if you call next again, there's 96 that did have issues. And the reason it doesn't add up to 100, just to show you, is because here you see we called repo equals next repos. So that consumed 1, and then what we had left was 99. So add them up together, you get 100. Okay, any questions with that?
Is there any specific benefit you get from using the item getter function as opposed to creating your own function and using Lambda? If the Lambda was in line, then you would have it twice.
Right, so the benefit you get over using item getter instead of a lambda is it's just easier to, fewer stuff you have to type. Yeah. So basically, if I'm doing anything that is just accessing fields, I like item getter. But yeah, you can. All you need is something that returns a function. So if you wanted to write a nested lambda, yeah, it's fine. So. Okay, so next we're gonna go over memoization. Okay.
Somebody when you sort, sorry,
Mm-hmm.
do the sort and then group.
Yeah.
If you fail to do that, do you get a run on that?
You don't get an error, but basically it's gonna group assuming it's sorted.
Okay.
So you're gonna wind up, in this case, there were 2 groups. So if you didn't sort it, you would get more than 2 groups. And it might be like, false 1, true 3, false. So basically it just, okay, how many trues are in a row? How many falses are in a row? Okay, that's a group. And it's just gonna keep making groups until it gets to the end, but your groups aren't gonna be accurate. So, exactly, yeah. Okay, so who here knows what memoization is? Okay, so a little more than half. So for those that don't know, so what memoization lets you do is, in this case, we were doing this expensive calculation. If you do an expensive calculation and you give it the same argument, you don't want to have to do that expensive calculation every time. So memoization is a way of caching the result of that function call so that when you call the function again with the same argument, you don't have to do the expensive calculation. You just use the value that was already stored in the cache. And so now I'll show you how you can use that concept to take this example we did before. Okay, so the first thing we want to do is kind of pull out the expensive part of the calculation. So here, where we're saying sleep, we're going to kind of pull that part out and just call it from within that function. Next, we have to use the function called LRU cache, which actually allows us to do the memoization. And LRU cache stands for least recently used. So there's different algorithms you can use for doing caching. And so in this case, once the buffer gets filled, it deletes the result that you used the least recently. So basically, if you are doing some calculation, whatever items you use the most, those kind of get saved into the cache. And then the arguments that you haven't used in a while, once your buffer gets filled up, then they get deleted. But for most people, this is probably going to be okay. Oh, sorry, I didn't explain that part. Let me go back. Okay, so this LUR cache, so we call it with no arguments. You can give it arguments to tell it how large of a buffer size you want. So what it returns is a function. And in this case, we're calling it a cacher. So what that function does, you look on the last line, is it takes the function that we want to create a cache for, and it returns a new function, which is like the cached version. So let me just stop there. Does anybody, or who understands this part? Just raise your hand. Okay, so for those who didn't, what part are you confused about? Because it builds up from here, so I don't want to I don't want to leave you. Was there anything about that that's confusing?
Can you say it just one more time?
Okay, sure. So there's a module called functools, and it has what's called LRU cache. And what that does is when you call it, it creates a function that we're calling cacher. And what cacher does is it takes the function that is expensive and it turns it, or it doesn't turn it, it returns a new function, which is the memoized version of that function. So the memoized version means when you call that function with the same argument multiple times, instead of rerunning the calculation, it just gets the result from what it saved in its memory. Okay? So now, you just have to know, right? So this is a functional programming conference, so if you're writing functions that aren't pure functions and you cache it, it's just going to return what you called with it the first time. So it just assumes that it's a pure function, and if it happened to be non-deterministic or perform side effects that you relied on, that's not going to happen. It's just going to save it the first time, and then every other time you call it, you just get back whatever result was returned the first time. Oh, so just to go back here. So basically we're creating a new function, right? So instead of taking the watcher's item, so in the function called calculate, we're just assuming we're passing it the result that we're going to be multiplying by 2. So previously we were saying repo and then square bracket and then string watchers. And so now we're just saying calculate isn't going to fetch the item in the dictionary. We're just going to pass it whatever that result was. So since it was using the watchers field of the repository, I just call it that variable watchers just to keep it symmetrical. So does that make sense?
And also, I guess the memorization has some overlap with storing the arguments.
Exactly, right. So the function that you're memoizing, it basically looks at the arguments that it's being given. So if you give it a dictionary as an argument, then that might not be as efficient as just giving it an integer as an argument. So yeah, it's a good point. So the function that you're memoizing, you basically want to limit how many arguments it takes and just reduce it to like the bare minimum that you need in order to perform your calculation. So, okay, so now what we're going to do is rename that function back to calculates, because what I didn't tell you is that LUR cache is something called a decorator. And so the decorator basically is a shortcut way of doing the stuff we did before, of kind of redefining the functions, doing all that, craziness. So this is just kind of syntactic sugar, an easy way to say, I just want to memorize one function. Yes?
You have to call it as a decorator? Normally you don't call decorators like that.
It depends. So this decorator accepts arguments. Some decorators don't accept arguments. And so if you go back to the slides before, you could see that when I instantiated that cacher function, I put cacher equals LUR cache, and then it had the parentheses, right? Because the LUR cache can take an argument which will say how large the buffer should be. So, but there are some decorators that don't take arguments. Yeah, it's a lot of higher ordered function stuff going on here. Yeah.
LR cache is a function that returns a function.
Yeah. So I know this might be a little difficult. So any other questions, just so I don't leave people? Yeah.
Decorator, wait, you call it here, you don't have to invoke it or...
Right, so let's go back. Didn't go back far enough. So this was what we had originally, right? So you see we're calling LUR cache, right? And it returns a function called cacher. And that function called cacher takes as its argument the function we want to memorize. So once we do the decorator, we're getting rid of that cacher variable, because the way decorators work, the function that's underneath the decorator gets passed in as the argument. So you see, so you see that underscore calculate.
Yeah.
So once we decorate underscore calculate, that automatically gets passed in as the argument to cashier. And we don't have to say cashier equals, because when you do that @ sign for the decorator, it automatically creates that cashier equals, and it says, okay, where's the function that's underneath me? And then it passes that in, which in this case is that underscore calculate.
I didn't understand that the next function after the decorator.
Right.
Okay.
Right. So this is the long way of doing it, right? And then when you use the decorator, you don't need these intermediate steps. You don't need the underscore calculate. You can just call it calculate, and then you use the @ to say make it a decorator. And now, since it's a decorator, the first def that's underneath it gets passed into it as a function. And what's automatically returned is a new function, which is the memoized version. Okay. Did you have a question?
Yeah, is this, is the LRU calculating in Python 3?
Yes. Yes, it's Python 3.
Decorator is also part of the language.
Yes, decorator. This is all pure Python, nothing fancy. Yeah.
So you can use a decorator, say you want to use it multiple times, you just call it for every function.
Yeah.
Okay.
Any pure function you can use the decorator. So the caveat is that you're trading off memory for speed, right? Because it's storing every value that you pass in. So if you decorate a function that only gets unique values, you're going to be wasting a lot of memory.
So when you call it calculate 1, the first time it'll take 5 seconds. The next time you call it, it'll come back immediately. Right?
If you give it the same arguments that you gave it before.
Yeah.
Exactly. That's exactly how it works. Yeah.
I guess I'm kind
Yep.
of confused. Why are we using this function to memorize? It seems like we want a data structure that memorizes.
That's a bit over my head.
Okay.
I mean, you could technically put everything in a dictionary if you wanted, but essentially this is doing that for you.
Because what we've done is we've created an iterator. And the problem with iterator is that we're losing samples. So I'm thinking, I guess maybe I need to understand where we're heading with this. I think the idea was that this memorization would solve the problem of us losing those samples that were thrown off the iterator.
No. That's not what it's solving.
Okay,
So
I was thinking
the thing that you when you lose items from an iterator by calling next, you can avoid that, but that's not what this is doing, right? What this is doing is this is avoiding us having to do this sleep 5 seconds if we're calling it with an argument that we already called before. So that's the thing that we're trying to figure out. Does that make sense?
Yeah.
Okay. Anybody else have a question? Okay. So now, and I'm kind of cheating a little bit, right? So I'm creating an iterator where the value is always 5, just to kind of, give a reason for, doing the memoization. If you were passing in values that always change, you're not going to see any benefit. So this is a little contrived, but I'm sure you may have examples where you do use the same argument multiple times. I don't think I use repeat yet. So repeat is another function in the itertools library. So whereas count started from 0 and went 1, 2, 3, 4, so repeat just takes an item and creates a lazy list or iterator with that item in an infinite number of times. Okay? And so now we have our new repos variable where the watchers in every item is 5, and we pass that to gen expensive rates. And again, we're going to use iSlice to get the first 5 items because it's an infinite iterator. And you wait the initial 5 seconds, but we're not going to be waiting 25 seconds because every watchers is going to be 5. So it says, oh, I calculated the first time, I saved the result. So every time you calculate the rate for a new item, it just does a dictionary lookup, and then you say, okay, the answer is going to be 10. Okay. Does anybody have any questions with that? Okay. So the first exercise. So I mentioned that I live in Arusha, Tanzania, So this is one of the mountains that you can see from Arusha called Mount Meru. Okay, so the problem is going to be display the total number of watchers per language. And we're still using the same things we talked about before. So it's the same URL, the same API, and repos is essentially going to be that list of repositories. So each field tells you what each repository has a field for the language it's written in and a field for the number of watchers. And the one thing to pay attention to is not every repository has a language. So if it doesn't have a language, you can just ignore it. And once you finish, the result you get should look something like this. So basically, a list of all the languages, and then the total number of watchers for those languages. So does anybody have any questions on what you need to do? Because if you don't understand what you need to do, it's going to make it difficult to actually do it.
What environment should I do this exercise? In the Python notebook?
Whatever you're familiar with. So if you can do it in the repo, that interactive browser that I showed you, you can do it there. So one of the notebooks is called exercises. So if you click on exercises, you can type right into there. Within the GitHub repo, there's a file called exercises.py. So you can use that. Basically whatever you are comfortable with. And this is in the source files, but the data source that you're going to be pulling from is the API here. So you're just calling the GitHub API, and you're searching for items with data. And if you do want to do it in the notebook, the notebook is that exercises.ipybn. So, and we'll do this for a few minutes. So I'll walk around. If you have questions, just kind of flag me down. If you want to work with somebody, that's fine. But all of the resources that you need are going to be in that GitHub repo. So make sure you look in that GitHub repo.